Hi, this is Dr. Gady, and I'm here to talk to you a bit and give you the benefit of my experience and talk about what we do with our curriculum, what are some things you should be thinking about, do's and don'ts, how things have changed, how things have stayed the same over many years, and what factors there are in an engineering career. Okay, so my sophomore year was different from your sophomore year. I went to Southern Methodist University, which is a liberal arts school that happens to have an engineering school. You go to an engineering school focused mainly that happens to have some liberal arts activity. Now, at my school and in Texas, football was kind of a big deal. I thought so, at least till I came to Alabama. And when I was in school, football was pretty big. We were ranked in the top 25, and things were going well in the old Southwest Conference, which we were a member of for many, many years. Then we got a little competitive and started paying our players, and we are the answer to the trivia question, what is the only football team to have ever received the death penalty? Well, that happened in 1987 after I was out of school. And the universities had a tough time in coming back from that, having gone through the Western Athletic Conference, the Conference USA, and now in the American Athletic Conference. Strangely enough, they are 4-0 at this point in the year and doing pretty well, but it was a long time. The football team is kind of like engineering. Things stayed the same for a long time, and then they started to change rather quickly, and we are in an area of really rapid technological growth. What does that mean for us? Well, we'll talk about that a bit. So what was going on in 1978-79 when I was a sophomore? Yes, it was a very long time ago. The Sony Walkman was invented. That was a personal listening device for music. And it was the first time that you could take music with you on the go. Otherwise, music had to be played on systems in your home. That's an invention that has led to our personal systems that we have now. The first birth from in vitro fertilization happened in that time frame. That was an important sociological event. The first Star Wars movie was 2 years old, Episode 4. I don't know that anybody believed at that time that we would still be watching new Star Wars movies all these years later, but we are. The IBM was the first major computer company, and they created mainframes where you went and you connected to a terminal to do your computing, which kind of we're doing again with cloud computing. We went through the personal era, and now we have software as a service. But IBM used to sell hardware. Now it's primarily a software company. And DEC, the company that made the VAX 11780, has come and gone. So what will come and go in your lifetime as engineers? We don't know. But this was a big deal in 78, 79, and that company doesn't exist anymore. Motorola still exists, mostly as a cell phone company. And it was in computing with the 68,000 processor that was used in the first Apple computers, and it was a 16-bit processor. So what was I taking as a sophomore? Well, first of all, I have to tell you that I was an electrical engineering student because computer engineering wasn't a discipline at that time. Computer science was, but not computer engineering. So circuits 1 and 2, statics and dynamics, because we wanted to be grounded in mechanical things as well. Calculus, differential equations, physics, labs. We didn't name them back in the day. We had EE Lab 1, EE Lab 2, and one of them had to do with an analog computer, which is just really old. But if anybody wants to see what those things looked like, I have a panel that Dr. Kulik has from an old analog computer that I could show you. And we did assembly language programming. And all those years ago, the professor started and said, why are we still studying assembly language programming when we have high-level languages? Well, good question, but we are still studying them because one of the reasons that we do it these days is it helps us understand the hardware. And also, that's where malware attacks are with cybersecurity. So assembly language programming is still a valuable skill today. Our first programming class was in Fortran. It's a language that stands for Formula Translation. And it was interesting. If you've never heard of a go-to statement, that was one of the only ways you could branch. It's similar to a branch and assembly language, but not structured programming that we have come to expect in C and C++. So there were things I was thinking about as a sophomore, and there were things I wasn't thinking about as a sophomore. And what you have to do these days is different from what I had to do. Career services were for senior year when I was in school. Oh, I guess I better think about getting a job. Career development these days is something that you should be thinking about from the beginning, or at least from your sophomore year. That's why we have a module for it in this mentoring class, and it's an important thing. Now, one of the things that I recommend to everyone is to have some sort of experience while you were in school. And I chose my university in large part because it had a large co-op program, and I knew that I was going to get some experience while I was in school. And in the Dallas, Fort Worth Metroplex area, there were lots of companies, so they were a lot of good places to work. This is similar to Huntsville. Huntsville has a lot of good opportunities for co-op, and it doesn't require you to move out of your residence hall. You can stay on campus, and you can just go to your job instead of going to classes. I was heavily involved in student life. I felt that was a way to really enrich my experience. I stayed on campus until the last semester of my senior year, and I enjoyed that. That turned out to be a good move for career as well. As Dr. Wells, one of my colleagues, is fond of saying, 5% of the problems are the technical problems, and 95% of the problems are the people problems. You get a lot of experience with people working in student organizations. I took the classes my advisor told me to take, or whatever was available. I was pretty casual about how I approached my so what happened? The first semester of my senior year, I needed 22 hours to graduate. So I took 3 hours in this special term we had in the middle of between fall and spring, and 19 hours my last semester. So in that respect, don't do what I did. Be prepared. Give yourself a reasonable schedule. Don't do things that work against your natural tendencies. If you are no good at 8 o'clock in the morning, don't take an 8 o'clock class. Put yourself in the best situations you can to be successful. All right, so you're going to get an engineering degree. We stand on the shoulders of people who have come before us. And we're engineers, we're not scientists, but we work with what scientists have done. You probably have gone into engineering because you like math or science, but maybe you didn't want to be a pure mathematician or scientist. You want to apply it. That's what engineers do. We apply math and science to solve problems. We are essentially problem solvers. Now, that does not mean that engineering is a math or science-free zone. So, what do these people bring to the table? We have scientists, inventors, and engineers. Scientists add to the knowledge base, inventors create new technology, and engineers use science to create and control technology. One of the examples I'll give you here is that the theory of MOSFETs, or metal oxide semiconductor field effect transistors, was known for a long time, but we couldn't make one until the inventors created technology so that we could make them. And then the engineers made them better, and we have triggered great revolutions in society and what we can do with applying the integrated circuit in many different arenas. So you are going to have an assignment where you need to go research some engineers, and here are the ground rules. You must be a name that is Wikipedia level knowledge, so it can't be Joe Schmerdlap. I know it's just a name I make up, but not eligible mom, dad, UAH faculty. Okay, who are engineers? Well, Howard Wolowitz, as entertaining as he was on The Big Bang Theory, is not a real person. Steve Jobs was marketing and business. Steve Jobs, without Steve Wozniak, who was the engineer, probably wouldn't have gotten as far in life. So, but he didn't finish college. Bill Gates, he did great things. He was smart enough to have good engineers around him. He also didn't finish college. And Elon Musk and Thomas Edison, Henry Ford, all wonderful people, not quite degreed engineers. Okay, so who are these people? Scientists: Newton, Einstein, Galileo, Curie, Heisenberg, Maxwell. These are people who have done foundational work. And then we have Edison, Bell, Ford, and Marconi. Edison, inventors have to be very good about failure. Edison invented the light bulb on something like his 1,000th try. And he said, well, I found 999 ways that it doesn't work, or something like that. But you have to be persistent. And we as engineers have to be persistent as well. So there's going to be a graded survey after this for you to do some exploration about engineering. Some of the engineers I want to tell you about are some of the pioneers in computing. So Glenn Jacob Culler was one of the original nodes on ARPANET. Wow, what was ARPANET? Well, it was the precursor to the internet. ARPA was something called the Advanced Research Projects Agency, and they envisioned the ARPANET as this way that scientists could exchange data. The internet was not developed to do business, but that is what it has been evolved to. But once the potential of the technology was recognized, everything has taken off, and we can't imagine our life without the internet, and the ARPANET was at the beginnings of that. Gordon Bell oversaw the development of that VAX computer that was big time in 1979. Lynn Conway revolutionized integrated circuit design. What does that mean to you? Well, how do you make our Apple Watch and our cell phones and all the chips that go into these things? John Matherly is so young that I was unable to really find a time. He's still alive. He might be as much as 30, but he's a big pioneer in the cybersecurity arena, particularly in internet connected devices, the search engine for secure devices. Cray, supercomputing. He was one of the first people to do parallel processing and do things really fast. In the day that he was doing it, it required so much power that cooling was a big problem and things had to be liquid cooled. Conway is an interesting character. He was a really computer scientist, combinational game theory, came up with something called the game of life. Sadly, we lost him in 2020 to COVID. Grace Hopper is one of the few females and pioneers in the area of computing. She was an admiral in the Navy. She created one of the first operational linker loaders, and COBOL, which is a language which has been used a lot in business applications. All right, so then we get into some of the more security. As we get computers everywhere, we have more problems because now people are finding ways to exploit that. And Morris created the first internet worm, malware that replicates itself. That was an invention. It was certainly something significant. And so now we have the whole field of cybersecurity and to try to protect us from things like that happening. Also in the arena of, so now we have the internet and we want to buy things online. How do we secure our personal information? So Diffie, Hellman, and Merkle came up with public-private cryptography. So the RSA algorithms, things to make sure that people can't get access to our information or try not to get access to our information. That's a very difficult problem. And perhaps one of the solutions to that is found in quantum computing, but it's just an arms race. We'll come up with something good to protect. They'll come up with something more to attack, protect, and it just keeps going. The first computer was created actually by a physicist. So that was at Iowa State back in the 50s, and that was a very important thing. So without the first computer, we wouldn't be where we are today. Okay, so what is the CPE curriculum? Why is it the way it is? Did we design it to torture you? That might be how it feels sometimes, but truly that's not what we did. So we have general, it's a lot like those at other schools, but there's something else that comes into it. There are standards developed by the IEEE and the ACM, Engineering and Computer Science professional organizations, that have said this is what we think should be in a curriculum. But as we go, we also have to ask ourselves the case, are we educating you or are we training you? So what does that mean? Training is something you need for the now. Educating you is positioning you to pursue a career in engineering. So you may be active in a career for the next 50 years. What will things be like 50 years from now? I can't tell you what things will be like 50 years from now, but I can tell you they will be very different. Whole industries will come and go in the time that you are working as an engineer. So what do? Well, we have to give you enough current knowledge for you to get the first job, and then we have to give you the fundamentals, the background, the problem-solving skills, and the motivation for you to go out and get the new information that you need. In some sense, about all we can do is teach you how to learn or encourage you to learn whatever. But it all rests on the fundamentals. All right, so let's take a point in time. 1950, we were starting to come into the computer age. And how were things different? Well, 10 years earlier, the first FM police radio communications happened. And 3 years earlier, the first hybrid transistor. And what does it mean to be a hybrid transistor? Where there were blocks of different materials that were connected together, as opposed to what we call a planar transistor, which is part of an integrated circuit. And 2 years early, holography was invented. 3 years later, color television, which was a big deal. The first cardiac pacemaker. The first integrated circuit, Jack Kilby, at Texas Instruments. I feel very fortunate to say that late in his life, I was able to meet Jack Kilby, because when I was a graduate school at the University of Texas at Austin, we had an industrial advisory board meeting, and there he was. I know that makes me really geeky, but there it is. All right, 12 years later, first transatlantic signal via satellite. Okay, so things are changing. 20 years later, video games, birth of the internet, personal computers, compact discs, the 486 processor. And if you're not familiar with that, that was the first, well, not the first. There was a 186 and a 286 and a 386, but it was one of the early Intel processors. And we had GPSs. Now we have Bluetooth, cellular phones, DVDs. What's going to happen next? Actually, 50 years later, it's 2000. We've come a long way, and we have a long way to go. So how do we position you to be successful? Well, we have to give you the fundamentals, and there's a lot you're going to learn on the job, which is why it's really useful to do a co-op or internship, because you get some of the training from that. You get different things from them. We have good things to offer. They have good things to offer. And being able to synthesize and put them together is really valuable and gives you experience when you graduate. So we have about 2 years of general education, math, science, and then about 2 years of fundamentals in the major. Some of you may have done your first 2 years at a community college. That's a great opportunity for you. And now you're getting into the major. What does that look like? Well, Some things are going to be fundamental, and some things are going to become obsolete, and some things are going to be new fundamentals. We have things that come into the curriculum at the graduate level. Hard to believe, but the first C programming class I had was at the graduate level, and now we teach it at the sophomore level. And that's what happens. We take some things out. We don't have those analog computer labs anymore. We have more modern things, but some things remain and some things come and go. All right, so what does your curriculum look like? Well, we have our Greek temple model here, where the foundation is the math, the science, the liberal arts, and FYE. And then we have some pillars of things that we think are important. In computer engineering, we have what I would say is, in general, I talk about the two pillars of software and hardware, but then there are some other things that we have to do, and they culminate in the capstone. So we have the software development pillar. You start in ENG 101. Computing has become so important in our lives that Steve Jobs has said it's the new liberal art. So we used to have computing only for some of the engineering disciplines, but now it's so important that we have ENG 101 and computer engineering. We do the most of it. We go through our classes and get those fundamentals in all those classes. So we have a depth in software. We also have a depth in hardware that starts with digital logic. We go from the bottom up. We have little building blocks that we're going to put together to become ALUs and data paths and computer organization. And then we're going to add on sensors and peripherals to go to embedded systems in 323. And then we're going to look at FPGAs and hardware description languages in 322. And finally, in 431, look at how cache memories and virtual memories enhance performance. But we have to understand that even though we do some things at a higher level of abstraction, fundamentally, we have current, electrons, things are flowing, so we need to understand some of the basics of electrical. We've grown out of electrical, and we have to keep some of those things so we understand that there are fundamental, real physical laws that must be obeyed. And finally, you have your electives. So most of you will kind of decide whether you like software or hardware more, and then you will craft your electives to fit in those categories. Or you might use these electives as exploration to say, I'm going to try something and see whether I like it or not. So you have 4 classes or 12 hours of electives so that you can personalize your education. Some advice, some final words. Do your homework, even if it's not graded. Many professors have tests that are strongly based on homework, so study it. The more you do it, the better you will become at it. Do take notes. Research has been done that proves that there is something about the process of you reading it and it coming into you and you writing it. Typing it on a computer is helpful, but they found that there's more value for you writing it. But people do work in different ways, but help yourself out and make yourself successful. Remember, we want to be successful. Now, it's okay to ask for help. Sometimes we were a high school superstar and then we get into something and, oh my goodness, it's not going the same way, and you think, I should be able to do this. Well, maybe you can, but maybe you need just a little bit of help. So I'm here. Dr. English is here. Dr. Guerrero is here. So contact us. Participate. Get those people skills. Go do co-op. Work on communication. There are skills that you need outside of technical skills. It's not enough to have the best technical solution. You need to sell your solutions. You need to be able to communicate. Faculty members are people too, and they might be able to help you. And if you develop relationships with them, you might feel more comfortable going to them on separate issues, and they might be able to help you. If they're not the right resource, maybe you need to talk to an advisor. Maybe you need to go to career services. Maybe there's something in student affairs that needs to help you, but they can point you in the right direction. All right, not to be too negative Nelly here, but channel your forces for good. Don't spend the time trying to get around the system. Just spend the time working the system, and it will work for you. Focus. I know you have many things to do, and that's particularly our focus is drawn away, particularly in this time of the pandemic. But you have a goal. You are here for your career. This is a relatively short amount of time. There are lots of time left to do some other things. So do the best you can with your college career right now. Now is the time. All right, last word. If you need help, get help. We're not born knowing anything. If you have questions, ask them. None of us can solve a problem that we are not aware of. So help us help you. Have a great day.